Welcome learners to my kcse revision channel. Teacher James Marita, Grigos Boys High School. Kindly subscribe to my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision paper 2 questions, that is energy changes in physical and chemical processes. So we have a diagram here where we have a thermometer, then we have a metallic container, then we have a lamp with ethanol. So we have the volume of water, which is equivalent to 450 cubic centimeters. The initial temperature of water is 25 degrees. The final temperature of water is 46.5. You can see now the temperature has increased from 25 to 46. Then we have the mass of ethanol plus the lamp before panning is equivalent to 125.5 grams. The mass of ethanol plus the lamp after panning is equivalent to 124.0 grams. So the mass of ethanol has reduced from 125.5 grams to 124.0 grams. And also we have been given the specific heat capacity from here. So we are supposed to do some calculations here and then we draw some energy diagrams. So to understand on how you are supposed to draw the energy diagram, you must know that there are two types of diagrams. One can represent an exothermic reaction. An exothermic reaction is a reaction whereby a lot of heat is being produced or released to the environment, and in this case, the value is negative. Another type of a reaction here is an endothermic reaction, whereby now the heat is being absorbed from the environment, and the value of heat is normally positive. So let us look at what we are supposed to do from this diagram. So in this diagram, first of all, we have the volume of water which is equivalent to 450. I want just to make this one as very simple, this one here. So if I want to make this one as very simple as this one here, is that the volume of water becomes the mass of water. Some other areas where you will be given the density of water is supposed to be 1 gram per cubic centimeter. So in this case now, wherever you see the volume of water, automatically that one becomes the mass of water. Why that? Because the density of water is 1. The volume of water is this one. So to get the volume of water is normally talking of the the volume of water, mass of water, it is the density times the volume. And since the density is just 1, so 1 times a number, it just remains the number. So you just translate this one direct, that the mass of water is normally equivalent to, it is the same as the volume of water. So we have here mass of water. So we can talk of mass of water. In this case, this one could be equivalent to be 450 grams. You just translate this one directly to the mass of water instead of taking the density of water, then you take that the density times the volume, which of course will give us this 450. So you also need to have the change in temperature, change in T. Change in T in temperature in this case, you take 46.5, you subtract 25. And if you want, you check the third one here, that change in temperature is giving us 21.5. So this one will be equivalent to P 21.5 in this case Kelvin. Another important thing that you are supposed to interpret from here, it is the mass of ethanol. Mass of ethanol, before panning, it was 125.5 grams. After panning, the mass reduced to 124.0 grams. So you also find now the change in mass. Change in mass now will give us the mass of ethanol. So in this case, you talk of mass of ethanol. Ethanol is C2 we have H5OH. So the mass of ethanol, you take 125.5 grams minus 124.0 grams, and that mass we get that one as 1.5. So this one here, this is 1.5 grams. So that is a very important information that you are supposed to interpret from this information you have been given here. I've said that you take the volume of water, it is directly the mass of water. Then you take the initial temperature minus the initial final temperature minus initial. This one will give us change in temperature. So our change in temperature in this case from here is 21.5 grams. Then you talk of the mass of ethanol. You talk of the initial mass, final mass, or the change in mass. In short, you talk of change in mass, 125.5 grams minus 124.0 grams. That one will give us 1.5 grams. Now, what are the questions we are supposed to calculate from here? Calculate the heat formed during the experiment. Calculate the heat produced during the heat produced during the experiment. To get the heat produced during the experiment is just very simple. You just say that heat produced during the experiment, heat is normally equals to P. It is the mass, and in this case, we are talking of the mass of water. It is not the mass of ethanol. Here we are talking of the mass of water. So you talk of the mass of water, times now here we talk of the specific heat capacity of water, which is provided as 4.2 joules per grams, and then now this one is multiplied by change in temperature. So you know we have all that. The mass of water is 450. The specific heat capacity of water is 4.2. Change in temperature is just 21, in this case 0.5. So this one will give us, if you work out that, you will get us 39, 60, 90. So you get this one as 39, 690, in this case, joules. That is how you can get the heat produced during the experiment. But there is something that you need to understand here. You check if the specific heat capacity, the SI unit in this case, is given as kilojoules per kilogram. So if the SI unit is given us as kilojoules per kilogram, then you are supposed to divide this answer by 1000, such that now we can have, we divide it by 1000, we have that in kilojoules, so we have this one as kilojoules. So you check this one very well here. So if the specific heat capacity is given us in joules per grams, then the answer remains like that one. But if the SI unit is given as kilojoules per kilogram, then you are supposed to divide this one by 1000. Then the next question, calculate the molar heat of combustion of ethanol. The molar heat of combustion of ethanol, whereby we have carbon is equals 12.0, the relative molecular mass. The relative molecular mass of hydrogen is 16.0, and the relative molecular mass of hydrogen is 16. The relative molecular mass of hydrogen is 1.0. The relative molecular mass of oxygen is 16.0. So how do you calculate the molar heat of combustion of ethanol? Molar heat of combustion of ethanol, it means the heat for only 1 mole. The heat for 1 mole. So what is now the formula of ethanol? The formula of ethanol is C2H5OH. That is what we have. So we have 2 carbons here, and then 1 carbon is 12. So you take now 2 times 12 plus hydrogen, we have 6. This one is 5 plus this one, so we have 6. So we plus now 6, in this case times 1. Then plus oxygen, we have 1 and 1 here, so we add 16. And if you add that one, is giving us 46. So the molar mass of ethanol is equivalent to be 46. Now, you calculate now the number of moles. So from here, you get first of all, you get moles. Moles in this case is equivalent to P. It is the mass. It is the mass given here. You divide by, in this case, the molar mass. You divide it by the molar mass. So the mass of ethanol was equivalent to P 1.5. So this one is you have as 1.5 all over the molar mass, which is in this case 46, and this one will give us a number of moles which is equivalent to 0.0326. So we have this is 0.0326 moles. So the first step will calculate that number of moles like that. Now from here, this number of moles of ethanol produce 39,690 joules of heat. What about 1 mole? 1 mole, such that now we can have the molar heat, So you just now from there that 0.0326, this one produces 39. So we have this one as 39. Then we have 690 joules. What of now 1 mole? So 1 mole of ethanol will be equivalent to, it is 1 now, then it's 39 and 690. In this case, you divide by the number of moles as 0.0326, and this one here now will give us as 1270. So we have this one as 17.48. So we have this is 12. So we have 17.48. So this one now you will have as joules per mole. That one is, you get that one as joules per. That one is you get that one as joules per mole. Now, the reaction here, there was a decrease in temperature. There was an increase in temperature. If there was an increase in temperature, it means that there is a lot of heat that was being released to the environment. So the type of the reaction here is normally an exothermic reaction. So the final value of the molar heat should be given a negative here. So they should be given negative 12 and 17.48 joules per mole to indicate that the reaction is high exothermic. Now, write the equation for the complete combustion of ethanol. Writing a complete combustion of ethanol, remember ethanol is a group of an alkano from organic chemistry, and what you know that any compound that contains carbon and hydrogen, once found in the presence of oxygen, there are only two products. That is the carbon dioxide and the water. So any compound that contains carbon and hydrogen. So ethanol is a group of an alkano, and in this case now, it contains carbon and hydrogen. So wherever you are finding that one, the only product you can get is carbon dioxide and water. So in this case here, the complete combustion of ethanol now, we have ethanol which is 2 carbons, then we have 5 hydrogens, and this is OH. This one is in a liquid form. It is pumped in the presence of oxygen. There are only 2 products you can have. So you will have this one as a CO2, you have carbon dioxide, and then you will have, in this case, you have water in a liquid. So you can have that. This is a complete combustion of ethanol. So we have 2 carbons here. We have 2 carbons. Then we have 6 hydrogens. So we can have that one 6 hydrogens. Then we have 4 carbon, 4 oxygen plus this one here 7. So the equation is balanced like that one. Then at the end of this one here, you should indicate that the heat produced is negative. In this case, 12, 17.48. In this case, we have joules per mole. That is how you write a complete combustion, writing a complete combustion of ethanol. In this case, you need to understand that any compound that contains carbon and hydrogen, when spun in oxygen, it produces CO2 and water. Now, the value of the molar heat of ethanol obtained above is lower than the theoretical value. That this value we are obtaining, the negative 1317.48 joules per mole, it is lower than the theoretical value. Why is it that? State the two sources of error in this experiment. What result, what the result, what are the errors that resulted to this value? Why did we not get the correct value, the molar heat combustion of ethanol? So instead of getting the actual value, we are getting a value which is lower than that. What are the sources of error in this experiment? So the sources of error in this experiment are just simple. So here you are supposed to state two errors in the experiment. Whereas one, there is heat loss to the surrounding. So we have here heat loss. So you talk of the loss, heat loss to the surroundings. Heat loss to the surroundings. Then number two, some heat is absorbed by the heating apparatus. So you also say here that some heat is absorbed by heating apparatus. So these are the two sources of error in this experiment. You can also be required to, how do you minimize this heat loss? To minimize this heat loss, we have this speaker, the metallic container. It should be secured, it should be wrapped with a tissue paper, and the tissue paper is secured with a rubber band. In that case, now to reproduce, you will prevent that, to minimize this error, or you will prevent the heat loss to the surrounding. We have another one here. State two factors to consider when choosing fuels for cooking. What are the factors to consider when choosing fuels for cooking? What are the examples of fuels? We have the charcoal is an example of a fuel. We have kerosene is an example of fuels. We have a cooking gas. Those are the examples of the fuels. Now, let us come to the fuels that we are commonly using in our homes. That is charcoal and the gas. What are some of the factors to consider when you go to the market, or when you go buying charcoal, or when you go buying cylinders, or when you buying the gas cylinders? What are some of the factors to consider? In this case, the factors to consider when choosing fuels for cooking. There, you consider, if you want charcoals, you consider whether this charcoal is available. So you consider the availability. So one factor here, you consider availability, if it is available. So you consider availability. After considering this availability, you negotiate about the cost. So you talk of the cost here. You can talk of the cost. You talk of how can you transport that charcoal. So you talk of transportation. You talk of the transportation. Then you can also talk of the heating value. So it's another factor. So you talk of the this one here. You talk of heating value. There are so many factors. You can also talk of storage. So you talk of also here the storage. And also, after talking of this, you can also talk about the pollution effect to the environment. So you talk of this one here, pollution uh, effect to the environment. So those are the factors to consider when choosing fuels for cooking. You consider availability, you consider the cost, you consider transportation, you consider heating value, you consider storage, you consider pollution effect to the environment. Outline two disadvantages of using hydrogen as a fuel. Disadvantages of using hydrogen as a fuel. One, hydrogen is expensive to obtain. So hydrogen is expensive. So you just say here, it is expensive. It is expensive to obtain. That is one. Number two, the reaction of hydrogen and oxygen is very explosive. So you can say it explodes. It is explosive. That is a mixture of hydrogen and oxygen is explosive. Draw an energy level diagram for the combustion of ethanol. Drawing an energy level diagram for the combustion of ethanol, you need to understand that the type of reaction here is an exothermic reaction. So if it is an exothermic reaction from this negative here, it means that we have the reactants on the higher level of the energy, and then we have the product at the lower level. So drawing the diagram here is very simple for understanding like that. And now in this case we are using this equation here. So you draw that energy level diagram. Draw that energy level diagram. So we have these are reaction parts. And then this side you will have energy. In this case, we have that energy in joules per mole. That is what we have. Then we have the higher level. We have the higher level here. And this higher level, this is where we have the reactant. The reactant is carbon, is ethanol, which is C2H5OH. This one is a liquid, and now this one is produced reacting with oxygen gas. Then at the lower level now we can have the product. So we have the product here. The product we have is CO2. It is CO2. In this case, plus water and liquid. Then you join this one here. So our arrows will be pointing downward like that. So we should be getting that downward like that. And therefore here is where we have the delta H, which is equals to negative 1217.48, in this case joules per mole. That's how you can draw an energy level diagram. Sometimes if you require to show the activation energy, so the activation energy is just shown like this one here, but in this case now it is not very much important. But if you require to show the activation energy, then you have to show that activation energy like that. So this is how you are supposed to draw the energy level diagram for the combustion of ethanol. For the combustion of ethanol, you will get kcse made familiar. You do a lot of practice where the heat of combustion of methanol. You practice on drawing the energy levels when the reaction is exothermic, when the reaction is endothermic. Thank you for watching. Click the notification bell, subscribe. You get notified once I upload a new video. Thank you.